There is a lot of information out there about balancing robots, and sometimes you can get a bit overwhelmed by the different way people use to get a balancing robot to work. I have chosen to use two high-speed servos converted to continuous rotation, an Arduino UNO for the processing, and a MPU 6050, which is a combined accelerometer and gyro sensor. The battery is just a 2-cell LIPO, and a UBEC is used to supply the servo with 6 volts. The Arduino runs at 7.4. On top, just for fun and to keep my 4-year-old little boy happy, is a full-color LED, which is used to show whether the robot is in balance, which is green, or leaning forward or back, which is red and blue. I initially started this project using a microchip PIC and managed to get quite far with it, including reading the MPU and filtering the reading with a complementary filter. I was using BASIC to write the program. But then I started to struggle with the PID, and at the same time I got into quadcopters and hexcopters using the multiwii board, and that introduced me to Arduino, which I'd never used before. So I ordered a kit from eBay and started to work out programming the Arduino with, I believe it's C. And it was very quick and easy. There are a lot of libraries out there which make the job so much easier. So I quickly got to the same stage I'd been with the PIC, and then using the excellent information from Brett Beuragards' blog, I got the PID control working. And once the PID values were adjusted, I finally, after about 1 year of off and on work, got my little robot to balance. Now it's still a work in progress, but to get to this stage was so rewarding. The PIDs still need tuning, and there are lots of other things I would like to do, including remote controlled and parameter adjustment via IR, correcting the integral return to zero problem, and shut off the motors on fallover, and so on. But for the time being, I'm just happy it works. So to run through how my robot works, firstly, when you turn it on, the Arduino takes average readings of the rotation or gyro in the x-axis and acceleration in the y-axis. This allows zero conditions to be worked out and applied to the calculations. Then we read the values, and after correcting the values using the above readings, we then divide the readings by 8 to get rid of the floating least significant bits. Then I put these values straight into the complementary filter. Most people seem to like to get real values in terms of actual angle and angle change per second, but I just use the values as they come, which seems to work. I'm not going to go into the complementary filter, as there's a lot of information out there about how it works, but basically it uses 99% of the rate of change value provided by the gyro data over a given time period to infer the current angle, and 1% of the acceleration data to correct offsets from the gyro. If you don't understand that, then check out the websites listed below. The result is a nice smooth reading which then gets fed into the PID calculation, and the output is then fed into the servo values. The routine runs at 100 times a second, or 10 milliseconds, and the servos are adjusted alternately, as they should be updated every 20 milliseconds or 50 Hz. There is a time correction part in the routine to keep it at 10 milliseconds, which helps the PID calculation. There really isn't much more to it. Initially I had the serial port connected so I could see values and adjust the PIDs and servo neutrals and error value, but that meant I was connected via the USB cable. So now it's truly running on its own. There are two other differences I've noticed from looking at other people's robots. Firstly, most people don't use servos. I'm not going to demonstrate why, but mine does work. And secondly, most people have an encoder to allow the robot to return to the same place if disturbed. Currently mine will just wander around. But because I know the zero values of both servos, I could add up all the offset values and return to the original position, which I'll try later. So there you go, this is my balancing robot.